Hello everyone, this is Meena Kumari from VVC Engineering College. I am going to explain about 8051 architecture. You may see that 8051 architecture have one AL unit. Has the size of the 8051 microcontroller is 8-bit. It performs 8-bit arithmetic and logical operations, and it has two registers, A and B registers, and it also have program counter, data pointer. Both are used to store the address. So the size of these two registers is 16-bit, and it have a program status word. The name it says, it shows the status of the current result, and it have RAM and ROM. ROM is used to save the data, and RAM is used to save the program. 8051 follows Harvard architecture. So the data memory and program memory both are different, and it has 4 ports: port 0, port 1, port 2, port 3, and each port size is 8-bit, and each port is with its latch. And it also have special function registers. Those are interrupt enable register, IP register, power control register, serial buffer, serial control, timer control, TCON, T mode, and it have two timers, and those are divided into two registers, TL0, TH0, and timer 1 is divided into TL1 and TH1. And also the memory is divided into banks. You may see that each bank is named as bank 0, bank 1, bank 2, bank 3, and it have some bit addressable area is also there. This is about the 8051 architecture. You may see the simplified architecture for 8051 microcontroller. It has program memory up to 4 kilobytes, and it has RAM up to 128 bytes, and it has two timers. Those are timer 0 and timer 1, and it has one serial port for serial communication, for long distance communication, and it has 4 ports. So those are port 0, port 1, port 2, port 3, and it has bus controller. And we connect here we have oscillator circuit. Actually 8051 microcontroller operates at 12 megahertz frequency, and it has central processing unit, and it also have interrupt controller. 8051 microcontroller supports up to 5 interrupts, and those again interrupts are divided into external interrupt, serial interrupt, and internal interrupts. This is the simplified architecture of 8051 microcontroller. Let us see the first component, that one is the ALU. ALU means arithmetic and logical unit, and it performs 8-bit arithmetic and logical operations, and also perform some bit operations. If you see the example, add A, R naught. Here the contents of both A and R naught both are added, and the result will be stored into the A register. Next, ANL, A, R naught, and it means logically ANDs the A and R naught, and that result will be stored into the A register. See the A register, the other name is accumulator. It is an 8-bit register. Generally, in most arithmetic and logical operations, A register hold the first operand, and the result will be stored into the accumulator only. And moreover, it is the only register to be used for data transfers to and from external memory. Next one, add A, R1. Here the contents of both A and R1 are added, and the result will be stored into the A register. Next one, move x A, at the rate DPTR. Here in this example, A gets the data from the external RAM location pointed by the DPTR. You know that DPTR is a 16-bit register, and it is easy to save the address. Here in this example, DPTR stores the address of the data, and that data is present in the external RAM. Next, coming to B register. B register is also an 8-bit register and used for multiplication and division purpose. You may see the examples: multiplication A, B. Here the contents of A register is multiplied with the B content, and the result will be stored into the AB register. You know very well, both the registers of size 8-bit. After multiplication, you may get the result up to 16-bit, and that 16-bit value is stored into the AB register. In division, div A, B. Here the content of A is divided by B. Here the result quotient is saved into the A register, remainder is saved into the B register. Next one, coming to PC counter, that is called program counter. Program counter is a 16-bit register, and it is used to hold the address of the next instruction in the program memory. Actually, you know that all instructions, nothing but program, is saved into the program memory. Actually, it saves the address of the next instruction. The address of the next instruction is saved into the program counter, and PC gets automatically incremented as soon as any instruction is fetched. After instruction fetching is over, whatever the value present in PC gets incremented by 1. That what makes the program move ahead in the sequential manner. In case of a branch instruction, a new address is loaded into the PC counter. Coming to DPTR, that is the data pointer. It is a 16-bit register. It holds the address of the data in data memory. Actually, RAM. Data memory is nothing but a RAM. RAM is used to save the data value, so it is the data memory. It holds the that data address. Holds the address of the data. Again, DPTR is divided into two types: 8-bit DPH and DPTL. DPTR is typically used by the programmer to transfer data from external RAM. It can also be used as a pointer to lookup table in row. Actually used in indexed addressing mode. If you see the example, MOVX A, @DPTR. Here A gets the data from external RAM location pointed by the DPTR. Here A gets the data from external RAM location pointed by the DPTR. You may see that whenever @ is present, that indicates from accessing from external memory. Next example is MOVC A, @A plus DPTR. Here A gets the data from ROM location pointed by the A plus DPTR. Next, coming to next one, stack pointer. It is an 8-bit register. It contains the address of the top of the stack. Stack is present in the internal RAM. Here, stack top of the address is saved into the stack pointer, and its range is from 00 to 7fh. And if you convert into the bits, total bits required to represent its address is 8-bit. So stack pointer is an 8-bit register. It is effective during push and pop operations. During push operation, SP gets incremented. During pop operation, SP gets decremented. Coming to program status word. It is an 8-bit register. It also called as flag register, as it mainly contains the status flag. These flags indicate the status of the current result, and the status is changed by the ALU after every arithmetic and logical operation. And program status word is a bit addressable registers. Each bit can be individually set or reset by the programmer. The bits can be referred to by their bit numbers, just like PSW.4, or maybe by their name. You may see the example. Set B PSW 3. The set means we are moving one value into that particular bit location. Clear means we are placing 0 value in that particular bit position. Here clear PSW.4. Particular bit value is cleared. That means keeping the 0 value in that bit position. Thank you.